So students, let's start. Sorry for the late little bit. So today we'll start sheet metal working in the NX. There is the additional feature of the NX. There is you can work on the sheet metal working. For example, if I open the new file. We have seen here the model assembly and here the drawing groups. Also here we have the NX, the sheet metal group that will directly work with the sheet metals. So for the beginning, let's open the this group. Here if open the sheet metal, you see there is several options related with the sheet metal working process in general. What is in the sheet metal working? I would like to give some brief idea about what is the sheet metal working. In the sheet metal working, you will work with the plates or metals, for example in this case the if we have assumed here the thickness, something thickness, and the thickness is the ranges between the 0.4 to the 2 to 6 millimeters. The thickness 0.4 to the 6 millimeter plates are called the sheet metal. And you know that in the sheet metal there is the some shapes can be directly obtained by the pressing, by the bending, or by the forging operation, that you can obtain the several the shapes with this kind of sheet metal with the plate. So it is the in the NX there is such a techniques directly you will obtain without any drawing. You will directly obtain such kind of shapes. Let me here show some videos to understand the meaning of what is the in general the sheet metal is the. Here you see the sheet metal is potted here with some pressing. You see directly the shape is obtained. This is the how is the, you see the thickness is the very thin, so it is the called the sheet metal. So you can obtain such a systems with the NX also. So let me see here the another example. Here the machine for the sheet metal. I will go here for the process. You see this is the metal. By the making the flange is obtaining this shape is by the deformation. So this is the how is the sheet metal forming is obtained. You see the thin walled elements could be obtained by the some machines, by the deformation, by the bending, and so on. So the NX will give us such an opportunity directly to obtain such a forms, such a bended forms, such a flange and so on, without any drawings and so on. So we have this kind of option in an NX to create such a sheet metal. So if you understand some brief idea what is the sheet metal, so we will start to go with making some examples on the sheet metal. For the beginning, here you see in the top is a tab. Always you will start to draw the system with the tab. It will be as an input raw material for our system, and making some changes to the tabs, we will create the workpiece. For example, we can create a tab in the two methods, by clicking the sketch or by directly selecting the tab. For the beginning, let's create the sketch, for example, as usual that we have done in the modeling. So in the create the sketch, you can create on the plane. So create on this plane, press OK. It is the same what we have done so far. So in this case, you can create any shape. Let's create the rectangle. So rectangle and finish a sketch. So in this case, I would like to create from this sketch the sheet metal. It is the tab which will serve us as a raw material. So select the tab. So in this case, select here the type the best and select here as a section, then select the curve, this one. You see, this is the extruded, but in this case it will be extruded as a sheet metal. Here the distance is 2 millimeter, but in the case you can make it is the range from 0.4 to the 6 millimeter to make the sheet metal. So let's keep it at 2 millimeter. Press OK. So this is our the tab. This is as our the raw material, and based on this tab we can create any kind of the sheet material by the editing it. For example, we can add here the this is the flange. We can add the flange, select the flange, and here you have to select any edge to create the flange for our this workpiece. This is our the raw material. Here you have the several options, the fulls, at center, and so on. We will see the all of them step by step. Let's start from the full flange. In this case, you have to select here in the first row, here to select the edge. You have to select the edge. You see, if you select the edge, it will become to flange. It will be banded. You can change it is the dimension. You see, it is the keeping that is total length. It will start to bend from this position. So with the length of the here 59, but you can change any value. Let's make it 50. So this is the how to create the flange. So in the reality, this kind of flange is obtained by the making some pressing operation and making the bending. So without any drawings, you can create such a flange in the sheet metal. This is the full flange. Also, you can create, for example, at the center. You see, it will become directly at the center in a symmetric way. So you can change the values here. For example, let's make it 40, and the length is the 50. Let's keep. You can change it is the direction in the downward direction and upward direction. So it is the downward direction. You see here, change the reverse direction. So this is the how to create the flange at the center. So let's make it full. It becomes full. Also, let's make see it is here. It is in the degree of the 90. So you can change it is the degree. For example, make it 45. It will be tilted. You see, you can put any value for the angle, 60, 80, and so on. Also, you have here the let's make it 90, and see from the this side, sorry, this one. So you see it is in the 90 degree here, and here we have the reference line, which is this one. This is the reference line, and here we have several options to create our the flange. For the beginning, here we have the, in this case it is the example of the inside. You can make it here the outside. You see that it measures this distance, and the inside it measures this distance between here to here. In the outside it measures from the bottom. It measures from the bottom from this side. It is if the inside it measures from this line, the distance here. For example, if you make it 50, it means this blue is the 50, and if you make it is the outside, this blue, this one becomes 50. This from the bottom. You see, it's the blue one. So also you can make here the web. In the web, you see, if you go to the here the 50, this distance is measured from the here at the start of the arc. In this case, there is 3 options to create the length reference: inside, outside, and web. So you can define any of them when you designing your sheet metal. So let's make it inside. Also, you can make the insert. That is here the several options. For the beginning, that material is inside. So the same way we will look here the reference. So it means that if it is the inside, that is the material is located on the left side of this reference line. If we will make that materials outside, it will be located to the right side of this reference line, which is this one. And if you make here the bent outside, you see here we have some offset in order to make the some to create this one. So you can obtain different insert, that is the material inside, outside, or bent outside. So here the options. Also here we have the offset. In this case, here in this example, the offset is the 0. You see the blue is to represent here the offset value. You can increase the value. For example, let's make it 10. The offset becomes here 10 millimeter from this reference line. You can change the value of the offset to this direction also. Yeah, you can give the any value. Let's see the offset. So let's make it the initial 0. And here we have the bend parameter. So the bend radius and the bend factor, neutral factor. In the bend radius, it is the standard. It's 3 millimeter for the sheet metal, but as you wish, you can increase or decrease this bend radius. Bend radius is this one here. This one. For the beginning, you can select this one and use the local value. And in this case, we can change the bend value. This one. And let's make it 10 to see the result. Press enter. You see the bend value is changed to the 10 millimeter of the radius. So it is the increase. So in the most cases it is a standard. For the sheet metal it's a 3 millimeter. Let's keep it. Also we have the relief, but in this case we see the relief with the other options. So let's go on here from the full to the center. In the center that we have seen, now we will see in a more detailed. Let's make it 40. In this case, from the center line, which is the reference line here, this reference line, it is the located with the width of the 20 from the left side and 20 from the right side, in total 14 millimeters. And this distance that represents the height of the fillet. Also here the angle, we can also introduce the angle with the, for example, let's change it 45. It will be bended, or we can change into this direction by the hand, so you can get this kind of thing. Let's go to the initial position. So and here the same, we have the inside outside web for the length reference. We can choose any of them. It is the better to see from this view. So this is the reference system. So according to this reference system, this one is the measure. This is the measure to the length. Here we have the locate the system from the right side or left side, as we discussed it before. So here the left side, here the right side, according to this reference line. Here the same, we can create the band, the offset for this one. So for example, the offset here, you see the offset is created. Let's make it 0. And here we have the relief, the band relief. Here what is this means. So here you see, here we have the rectangular shape. So in order to change this rectangular shape, for example, here it is the select square. For example, if you select this rounded, you see that here the relief becomes the round. So this is this value. Here you can make it square, or also you can change the dimensions. So for the begin, select use the local value and make it, for example, the 6. So you change here the length. Also with you can change the width. Also use the local value. So you can define any value, but standard is a 3 and 3 in the cases of the relief dimensions. So this is the how to create flange. Now we will continue. So we can go again flange, select the flange. Here the select, for example, the at end. the method of the at end create the flange. In this case here the select the edge, this edge, and here to specify the point, and you have to specify the point where you want to start your the flange. In this case you can select this edge or this edge. So this point, let's select this point. So the flange is created starting from the this point, starting from this point, and with the angle of the 45, let's make it 0. So this is the distance of this flange, so you can increase it at any value. So and here you can the same length reference as you want. You can inside, outside, or you can make it web. So and material inside, material outside, and so on. Here the same feature, the offset, band radius the same. Also here we have the relief, band relief. You can make it rounded here or square it the same. The just difference is that here we have to start from the end. You can here the change the specify the position to this one. It will be changed to this end, so you can make any value. So here is the width is defined. Here is the length in this direction. So this is the how is the flange with the options of the at end is the created. For example, this is the initial, this is the tab, which is this rectangle tab is our the initial reference raw material. We assume it as a raw material, and if you go to the feature of this tab, double click the tab, and if you change here the direction of this tab, here if you select here the direction is you see it in upward direction. If you change it to the direction, the downward direction, and press OK, you see the flange direction is also automatically changed according to this reference tab. So because it helps us to change this one, press OK, and now it is the upward direction. So let's go on to see the other options of the flange. Create any flange. You can create the flange here from the center, from the end. So it means that the measures the distance starting from any end that will start the flange. For example, here the select the edge. Now select the point that we want to start with the offset of the plane. This is this point. You see here after the 41.25 millimeter, here this blue starts the flange with the width of this one. You can change it one. This one let's make 30 smaller. It will be moved here, and you can change this one also. Let's make it 60, and so on. You see it will be becomes the 60 millimeter. So it means that if you go here the from and this one 30, it means that this one is the 30 millimeter, and this one is the 60 millimeter. The same options you can change it. It is the length reference as usual. That is the same, and the material inside and outside. You can insert offset, band radius. You can insert here the band radius. Also you can here we have the relief. You can make it rounded, and you insert any values for the relief. In this case is 3 and 3. That is a standard value. Press OK. So now again I select the flange. Here we have the last option to create the flange from the both ends. In this case the same for the beginning, select the edge. So in this case you see it will create now for the beginning as a default it create the flange directly in the middle, the same distance here from this distance and this distance is the same from the both edges, but you can manually change the values. You can make it the same or different. For example, you can make it 60 and for example 40 from this edge, and automatically this width, this width will be defined. This is the legs of the flange, and this is the angle of the flange. So you can locate it symmetrical or asymmetrically as you want, so from the both ends of the system. And here angle the same. Here the parameters of the length reference, the materials references, and the offset the same. You can make the practice. Here you can drag this one, you see, and so on. And here the bent angle, bent radius, the relief, you can make it. It is in this case it is the rounded. So this relief here, let's make it here the relief, you see. So make a offset 0 and so on. Press OK. So this is the how to create the flange with the several options. And for example, you can add any base, here. This is the base. You can add any base for this initial base. In order to do this, you can select the sketch, select this face, press OK, and here for example select the rectangle and start to draw the rectangle from this height and top here. Finished all. Now I would like to add as a new sheet, metal sheet, this rectangle to the initial base. In this case, you will go to the tab again here. Before we use it to create this one as a base, but in this case, if you select as a secondary and select the curve to this one, it will be automatically added to this base to become the single sheet. So press OK. The same way you can start to add any more sheets and create your model. So this is the how to create the tab. We have seen how to create the tab and how to create the flange with the several options, and now we will see the more advanced. It is the how to create the counter flange with some several shapes. So in order to do this, let me open again a new file. Okay, the layout, I will select the sheet metal and press OK. So the same, I will start with the sketch or directly select the tab. In this case, let's select the tab, and in this case select this plane to draw the reference sketch. In this case it's a rectangle, and if you finish it, it directly be extruded as a sheet metal. In the case is the tab, press OK. Now I would like to add for this tab the raw material. This is what is called the contoured flange with the complex shapes in this case. So let's do it. Select this one. It will typically go to the secondary because it will be added here, and here select the course. You have to, for the beginning, you can create the select, or you can create the sketch or directly draw the sketch. Let's draw directly here this one. Select this one, and here select the path, for example this edge, and let's make it here the arc length. This is let's make it 0 exactly on this position, the plane, and press OK. The plane is created. Now we will, here the plane is created, you see. I will rotate it a little bit, and I will create in this plane the curve. So for example here, select the profile, selected, start to create the curve from this point, like select this point, continue it, any sketch, so I draw it, and finish it. So we say it is the created. Since we are in the counter flange, here this is the created. Now you have here the several options, the finite, symmetric, to end the chain. So here the select the finite. You see, it means that this is the extruded, like we have seen in the swap function. So it is the extruded. Okay, I will go back toward this question. Okay, just a moment. So okay, what here, this is the distance. So it is the how to extrude this one is the finite. So you see, this is the sketch is the extruded with the width of the 3 millimeter and with the distance of the 87 67, and here you can change it is the bend radius and so on. So here the distance, so you can define the any distance as you want. So you can make it 80 and so on. So this is the how to create this kind of system, the counter flange with the finite method. So if you select the symmetric, in this case it will be symmetrically located here between this system. So here we have the in the outside, so we don't want such a system. So also you can make it to the end, so it will directly extend this sketch until the end of the system, which is the here, which is the ends here. So this is the one. Also there is also one more advanced option. It's the chain. In the chain you have to select the edges to be extruded. This is the to be extruded of this one. So in this case select the edge and start to select the edge for this one, but you have to at least select two edge in order to extrude. So one is the selected, the second one this one, so it is extruded, you see, and you can close it, this one and this one. Press OK. So you can obtain such a system, such an element. You see, it is a sheet metal. It is the metallic element sheet. So it is such a system. So here you see there is some. You can make some changes here in the between these two sheets. So in order to do this, you can double click here. Here we have the several options here. Not here, just a moment. Okay, we can make it using this one. Here you see the option is the closed corner. In this case, select the closed corner. So here you have to select the bands. That is the bands to close. Here in this case, this band and this band. You see here it is the option is the closed. So it is the closed. If you select the open, it becomes open. Let me zoom it bigger here. Now it is the open. If you want to make the close, this I select this one and this one here, and it is open. If you want to make the close, select here the close. It will be closed. Also you can make here the closed or overlapping such a system or closed. Also you can say make the closed system with several options. For example, circular cutout. You see it will be circular. You can define it different here. U cutout in the U shape, V here the V shape, and you can rectangular and so on. But it is the most cases. Let's make it closed. So here this one. So press OK. It will be exactly closed at this point. If you go here, it is the open here. Here is the closed. So you can close this part also. Go to the closed corner. Select this blend and this band and it is the closed. Press OK. So the same way you can do for the other parts. Close, close, then apply, and you can go for the other, this one and this one. So this is the how to create the counter flange. So with the several options, the chain, to the end, symmetric and finite. So with the several options. So sorry, here directly you can create the same what we have done here. I just missed it here, the open closed of this intersection between the two flanges, counter flange. So we can go on. For example, if you add another element for this element, for example, here this which is the color is the lower. So it is the open some lower for the sheet metals. Let's do this. In order to do this, select the sketch, and here the select on plane, this plane, select this plane, press OK. I would like just sketch just a line here. This line, define it is the dimension. So let's define it is the dimension. Okay, let's keep it 40. Let's make it 30 in this case, maybe. So we can move it a little bit here and finish it. Now using just this line, I would like to create this is what is called lower. So press the lower, and here select this line. You see such a system is created. Sorry, I will rotate it a little bit here, double click, and you can change it is the direction, not here, in this direction. Maybe you have seen such a system in the sheet metals open system. Here you can change it is with the layout, like you see the rectangular like this, or with the format one like this. It is what is the called lower. It is the obtained by the some cutting and pressing operation. What is the doing the here the old operation is the obtained by the some machines like pressing, the forging, and so on. There's some bending and so on. This is also the obtained by the some operation. So without any sketches, so with the some obtained with the machine. So it is that is low. So also in the sheet metal we have the function is the pattern the future, which we have seen before in our the modeling environment. So we can pattern such a features in a sheet metal also. Go to the pattern. The same we have the several options, the layout to make the pattern what we have discussed, that linear, the circular, polygonal, and so on. Let's make it see the example of the linear one. So here in the first row you have to select the feature. There we want to make the pattern. In this case this is our the lower which we created. Select this one, and here specify the vector. So in this case let's make the pattern along this axis. So it is the created, you see here 1, but here let's increase the value. So let's make it 5. Let's see the result. So let's make it 4, and little bit increase this distance, and just press OK. So there is, let me okay, let me check here this one. Okay, let's keep it here. So now let's try to make the pattern, this one. Sorry, you have to also select this is the let's make it for the beginning the locate it like this as a first one. In this case, when you make the pattern, you have to also the select here it is the pattern sketch. In the pattern sketch was this one, so you have to select this one, and also control select press the control and select this one here. It should be the 2, so now I hope it works. So linear one, specify the vector this one, and the number is let's make it 4, so press OK. Now it's okay. So you see the mistakes was the when you select here the feature, you have to select the sketch which we draw here the line, and as well as the lower. So press OK now. So this is the how to create this kind of logo. So we can continue. Let me see here the okay. I will say open the new file with the sheet metal. Again, create the sketch on this plane. So okay, I will sketch the rectangle as a base in a rectangle and finish. Select the tab as a raw material, so this one. Okay, so let's make flange here. Full, and let's make it angle 90. Press OK. So here there is some options here in the right side of the window. You see the unbend, bend, and the resize bend, and see how we will see these options also. Here the unbent means that we have here the bended option. Let's make it 45 to see the our result. So here. So here we have the unbend. Unbend is the making the bended feature, bended flange to the initial condition. So in this case, you have to select the face for the beginning, that is the stationary face. So in this case, this is our stationary face, and the select the face where we want to make the bend is to the initial. In this case, this bended face. So select this one. So you see it will become directly in the 0 degree. So if you press OK, it will be unbended in order to see the result. So if you go here, you see it show that it is the initial condition. So it is a very useful tool when you work with the sheet metal. So in order to see analyze the sheeted metal in the unbended condition. For example, let I delete this one and make it 90 degree, and here the create again flange here with a 90 degree with the reverse direction. Apply this one, apply this one. Okay, so this is the workpiece. If you assume this is the workpiece with these shapes, and if you would like to analyze it is the unbended condition, you go to the unbend, so and start to select the faces. For example, as a stationary face, select this one, and a bent face you have to select these faces. So this one, this one, this one, this one. So you see now you can analyze this one, and it is useful when you making some drafting, so putting the dimensions and so on, you will analyze it is the unbended condition. So if you go here, it shows it is the original positions of the system. And if you would like to return to the initial condition, here is a function is the rebend. In this case, you have to select the face you want to make it is the initial condition. So you have to select this face. So it will return here this face, this face, and this face. So in this case, you see it will returns to the initial condition, which is in the bended condition. So this is the how is the unbend and rebend function is the working. So here also the can resize the bend radius. So this is the bend radius. This is the standard, which is the 3 millimeter. So you can change it is the bend radius as you want when you already obtained the model. So select resize the bend radius, and here the select this one, and here it is the one you can make it 3 and so on. Press OK. So it is the change it. So it is the how to the bend this one. So also you can resize the bend angle. Here this one, and you have select the face or the edge. So select this one here, and then select the just a moment. Select here the stationary face is this one, and select the face is the bend is this one, and you see it is the 90 degree here, exactly the 90 degree. You can change it to the angle with any value. So press OK. So you can change with this option resize the bend angle. In this case, for the beginning you have to select as a stationary face, for example this face, and to select the face which is the bend, in this case this face. So here also one more option, it is called normal cutout. It is the useful option to create several shapes and cutouts on the surface of the sheet metal. So in order to initiate this normal cutout, we have to create any sketch on the surface of the sheet metal. For example, create the sketch, select the sketch. As usual, for example, I would like to create any shape in any sketch on this surface. Select this surface and press OK, and here I will make it rotate. I would like to sketch here the circle and finish the sketch, and this is the sketch, and I would like to make the cutout along this side. In this case I will select the cutout and select this. You see it will be cutted. In this case it is you see it is a simple circle. In this case it is a simple circle, but you can create any shape. For example, you can create rectangles and so on. Any complex shape you can create also. Let's see for the beginning the rectangle. And so on. So this is this option, how to create this option. Okay, let me open the one file. Let's see some examples for the end of today the course. Just a moment. So to make some practice, where is the sheet metal? Let me this one. So let's see for the beginning this one. So you can see here this kind of elements could be generated. This is the sheet metallic element. So let's try to do this together. So I'll open new file of sheet metal group. So press OK. As usual, I will go for the beginning the sketch, select the plane, and create the reference line. I mean the rectangle. I will not put any dimension. Go to finish, select the tab, extrude it. So I will create flange, just a simple flange. This one, apply. This one, apply. So now I will go here the closed corner to close these corners. So here select this face, so see it is the closed, here the closed and the closed here. The same way I will go this face to close this. Close all the four sides. Let's decrease the flange length smaller. Let's make it for the all. Let's make it 20 here. Last one. So also now you can add here go to the sketch, select maybe we can create directly flange, try to create the flange here, not the full, but let's make it at center on this one, and let's make it the width, let's make it 60 higher. I mean the not the I mean here the 40 width, and the distance smaller. So you can create the same flange on this side, or you can use in the sheet metal also have the mirror option, the same. You can create the whole mirror and the same elements. So go to the mirror, select a feature to make the mirror, the same methodology. Sorry, it is not symmetric, but we can solve it using the new plane. Create a new plane. So create a new plane. Here the new plane. Create the new plane. We can create the plane as a bisector, middle between this face and this face. You see, it is created, and press OK. And OK, it will be just mirrored this element. Also, in here you can create the hole. Go to the more here in the sheet metal. Also, you can create the hole. What we have seen in the modeling, the same method. So for the beginning, select here this face to locate your hole. It is located here, but you can put it in the dimensions. Distance from here to here, let's make it 10 millimeter, and distance from here to here, let's make it again 10 millimeter. If you finish it, hole will be created. So it's okay. You can increase the value of the hole here. It was the diameter 2, let's make it 10. It is too big, let's make it 6. So we can make it pattern. of this hole, the linear direction along this one, change the direction. Here let's take it 2. The same way we can make the mirror of these holes. Go to the more again, mirror feature, select this hole and this hole. In this case select the new plane again, create the new plane. It's a bisector between this one, that is exactly created on the middle. Press OK. Okay. You can here also we have the one option. It's the called a break corner. It is the what is the we have seen in the modeling is the making the edge blend on the sharp corners. So select the break corner. So in this case I would like to make the corner of the edge blend on this corner. So it is not selecting, sorry. So I will go here. Okay, selected. This one and this one. You can here the diameter is 5 millimeter. Same way you can make it here. Here. You can also make it a chamfer using the same option, break corner. In this case you have to select here the chamfer. Let's make it here the chamfer, for example, in this corner. Sorry, let me make it again. Okay. Sorry, it is not selected. So right corner, chamfer, this one. Go to the second side. So you see, this is the how to obtain that element. Also, let's make the another element again that we have seen is lower. So it is the most commonly used features in the sheet metals. In order to do this, let's sketch the line here. So okay, let's keep the dimension same. Go to the lower hole, select this one. So you can here the reverse direction, not this one but this one. Also you can here the, let me and press OK. You see it is from bottom, you see it is the opponent element. So can again make the pattern, the linear one, select this one, and also select the sketch control and select this one. Now select the vector, reverse direction, make it maybe 3. One more option we can create here, for example select this one, select the circle here. So here we have also the one option, it's called is the dimple. So select the dim one and you can select this circle. You see this kind of element is created. You can change the direction and here you can make it like this. Make it so you see the dimple is created. This all is the, you see, processes is created by the pressing operations and so on. So by the pressing, you see this kind of element created in the sheet metals by forging and so on. We have seen the forging and pressing operation. So there is a special machines is to use it to create such a features like this one and this one also with this one is the bending and creating such a system. So it is the useful in NX to create such system with the simple methods and so on. You will not sketch and it will be difficult to use the here the modeling. If you go for example application and in the modeling it will be difficult to create such a system, but with the help of the sheet metal you can create such a system with easily with for the processing operation. So can hide the sketches, hide the coordinate system. So such a system you can create by yourself. Go to the view, select the element, color, so let's define the different color. So this is the was the about the sheet metal, and tomorrow we will see the other options of the sheet metals. Now we will see this import these ones and these ones. Now we will try to see the other options to create too late. So to create several features, we will see how to create several features here with the several options for tomorrow. So this is the just introduction of the about sheet metal. It is the important thing is to you always create with the starting with the tab and start to change it is the shapes and add several features like the holes, like the lower the dimples and so on. With the here the edge balance with the chamfers and so on can create your element your project. So there was the question, the one question that was how to choose the length of the hole for the screw. Uh, I really I don't understand the question, but you mean in the question is related with the NX or with the software, or you in the general? Sorry, could you clarify the question about the screws, the length? I think the Leonid is not here, he's just left. Okay. So this is was about the sheet metal. We will continue tomorrow about the sheet metal with some practices with other options as I mentioned here. So do you have any question related to the sheet metal or with the other option or with the other? Do you have any question? So then unfortunately you are a little bit late and we are almost of the finishing our the lecture for today. So if there is no any questions, students, I would like to finish at that moment. Okay, the thing. Okay, don't worry. Just try to next time to be attended in the on time. Okay, okay. If you don't have any question, then we can finish at the moment. Thank you very much for the participation for your patient. See you tomorrow at the same time around 2 o'clock we will start.